Hello everyone, my name is Sushant Gautam. I am a master's student from the Institute of Engineering at Tribhuvan University, Nepal. The paper I will be presenting today is titled Soccer Game Summarization using Audio Commentary, Metadata and Captions. This work is a collaboration with the Simula Metropolitan Center for Digital Engineering, SimulaMed in Norway, as a part of my master's thesis. It is well known that the soccer is the most popular sport with over 4 billion fans. Imagine if we missed our favorite match. How would we prefer to get updates on the missed matches? Summaries, right? Text summaries are good choices as they have powerful expressive advantage and can exist in multiple forms. Such summary could be one-liner as in tweets, multiple lines as in video description, or even couple of paragraphs like in news article. Soccer game summarization is of tremendous interest to both broadcasters and fans. There have been notable researches around automations in soccer production pipelines, mostly around event detection, event clipping, action recognition, and video summarization. However, there is a research gap in automating text summarization end-to-end into soccer video production pipeline. We believe that multiple resources like game metadata, captions, and audio intensity can be utilized in generating soccer game summary. In this research, we are questioning the possibilities of automating soccer game summarization with available data like game captions, structured event information, and audio intensity data from the game field. The contribution of this research is a pipeline that can generate soccer game summaries from multiple input modalities. We also created an open source and audio intensity dashboard to visualize the relationship between events and audio intensity levels. To bridge the gap, due to lack of appropriate dataset in English for soccer game summarization, we extended three existing soccer datasets, SoccerNet, SportSum, and KSportSum, from a game summarization perspective. This is the block diagram of the proposed system that would handle three different input modalities. The input data can either contain videos, metadata, captions, or any combination of three. Let's see the function of all the blocks in the pipeline one by one. To be clear, we ignore the visual component of the video in the pipeline and utilize only the audio part. Audio is extracted from the game videos using FFmpeg library into either WAV or MP3 format. Various types of noise are inherently present in the audio streams of sporting events. Such noise include crowd cheering, instruments playing, etc. We particularly use Splitter by Deezer to extract audio of women commentators. Splitter uses a machine learning based noise filtering approach. It splits the noisy audio into clean commentary audio in a residual file. The clean commentary audio is later utilized for speech to text purpose. The root mean square audio energy data is calculated from the audio extracted. Higher root mean square intensity indicates higher excitement among viewers and commentators. This information will be later used by the priority filter to select relevant events for summarization. The clean audio from the denoiser will be processed by the speech-to-text system. We use IBM Watson here. The output will contain the textual form of women commentary in the game. A metadata parsing module can parse data from different datasets and systems into a common representation. The template engine uses its static knowledge base to generate captions from the structured metadata input. This is what static templates look like. For different events in the metadata, depending on available information, there are templates that are filled up with available information to generate captions. Captions, either from dataset or generated from metadata, are fed to the trained natural language generation module as per the configuration to generate expected dynamic text summaries. We particularly fine-tune long-former model in this work. Training a transformer model is straightforward. We just need input reference text and expected output text pair. Input reference text can be generated from a template engine utilizing metadata. I talked about this earlier. The expected target summary is the standard content that is almost handcrafted from existing resources like news article. The long-former in this work has been trained for 10 epoch till the cross entropy loss settles to a stable value. Another interesting module in the pipeline is the audio priority filter. It contains a rule-based and root mean square audio calculation function. It filters the audio content according to root mean square intensity at that particular moment when the event happened. The purpose is to control the length of the summary by including only the important events. Depending upon the availabilities of input modalities, we have three families of method to generate text summaries from the system. To recall, the input to the pipeline can be either commentary audio, structured metadata, or captions, or some combination of them. Considering the denoising and priority filtering module is optional module, there can be 10 different combinations this pipeline can run through. Let's see the working of each family in detail. This is method family 1. The input is structured metadata, which is parsed and converted to captions through a template engine. Audio priority filters can be either turned on or off depending upon the need. Denoising module can also be turned on or off depending upon whether the root mean square of game audio is to be considered in priority filters. This is method family 2. The audio extracted from the video is fed to the speech to text system. We use IBM Watson here. The output is timestamped commentary audio text. Such commentary audio text can be again filtered with audio priority filters with an optional denoising process. The final family is method family 3. This method utilizes a deep learning based model for text summarization. The captions are fed to a fine-tuned transformer based long former model which generates a textual summary of the game. The captions can also be filtered with audio priority filters with an optional denoising process as before to remove unnecessary information. We use multiple datasets in this work. The first one is WOS dataset, which is curated by Department of Holistic Systems at Simulamed. It has 20 annotated videos with 9 different action events. The metadata contains timestamp detailed information on the events, players, and teams. This metadata format is used as a reference for further work. The SoccerNet video dataset has 17 tagged action events annotated in 500 different soccer game videos. As the dataset is aimed at action sporting, it lacks event details like in host dataset. So we extended this dataset from the perspective of soccer game summarization. For the 278 games of SoccerNet dataset found on BBC's website, we scrapped news, captions, lineups, and match stats information. We also extended a Chinese dataset called SportsSum, which was aimed at soccer game summarization. The dataset contains 5,000 plus commentary and news pairs in Chinese. However, the scope and length of news are large in this dataset. The news also contains information which are not related to the particular game. We translated all of the commentary and news information on the dataset into English. We experimented with structured information extraction using OpenAI GPT-3. We fine-tuned the OpenAI GPT-3 text DaVinci model with a few examples to output JSON structured information on events from the text captions as input. This is particularly important in situations when we only have captions. We could extract event information which can be used for downstream tracks like filtering. For example, we can prioritize captions containing goal events in the summary when we know which particular event the caption describes. We extended another Chinese dataset called K-SportsSum aimed at soccer game summarization. It has 7,000 plus commentary and news pairs in Chinese. The dataset has better quality as it has used a manual killing process to limit the scope of the data. We also translated the commentary and news information in this dataset to English. The English version of this dataset was only used in training the long former model mentioned before. As it is commonly used by other related work in the literature, we use variants of Roos metric for evaluation of the output summary of the system. This is the preliminary results for representative model from all the families in terms of Roos score. We can see that the result from method 3.1 have the best results over all others. Let's see the results one by one. This is the pipeline output from method 1.2 representing method family 1. As you can notice, the sentence structures are very redundant and boring to read. It is because of the static template used in template engine. Since method 1.1 contains all the results generated with metadata as input, the output is very large, containing all the events in the game. This method contains the complete information of the game. Method 1.2 is the output after the use of priority filters as per audio levels in the game. The length of summary can be controlled with the filter module. Still, the sentence structure are very similar and boring to read because of the use of static templates. This is the pipeline output from method 2.4 representing method family 2. These texts are straight from the speech to text results from the audio of main commentators in the game. The result is very difficult to put into context. Since method 2.1 contains all the results generated with speech-to-text of commentator audio, the length is very large and not suitable for summary. Method 2.4 filters the text spoken by human commentators using the audio RMS label, so it's shorter. It's natural that commentator talks not only about the game event but with broader context around the game, so the sentences are difficult to put into the context when filtered. For summary purpose, this family is the worst for us out of the three method families. This is also could be due to the problem with speech to text of audio, which could have been affected due to the quality of audio in the dataset or accuracy of speech to text system or even efficiency of the denoising model used. Now, this is the pipeline output from method 3.1 representing method family 3 using long former. This is the best output to use among three families. The summaries are shorter and relevant as they contain only the key events in the game. The output also follows the data pattern of the summary in the training dataset. Therefore, long-former demonstrates the potential to be used for soccer game summarization. By the nature of the model, the maximum input to the transformer is always fixed. However, long-former model permits over 16,000 tokens as input. The good thing here is also that the output can be adapted as per the requirements to some patterns or configurations by providing proper training dataset. This is the loss curve while fine-tuning the long former model. It was trained for 10 epochs with the maximum output length set to 1024 tokens over 6 NVIDIA V100 GPUs with a per device batch size of 6. These kind of systems have very high value in the sports industry and have potential applications in multiple domains. The pipeline can be integrated into commercial broadcast soccer production. This kind of system can directly supplement automatic sports news generation. Soccer clubs and sports websites would benefit from social media automation and content creation. Video summaries are also useful for search indexing, SEO, and from a general information distillation perspective. There are multiple limitations of the pipeline as of now, as well as open challenges for the community on the field of soccer game summarization. We have only experimented with English language summary. This can be extended to support multiple languages. The available captions and languages used by the annotators are in different languages as per the audience in the game, in the video. Future systems can support information with different languages as input. The system currently can output only text summaries. However, this is a good thing from the accessibility viewpoint that the text can be easily converted to audio, which can be useful for people who are not able to see. The current system depends on events from the existing system or pipeline. The accuracy of information in the summary is therefore directly affected by the events available. The metadata format can be different depending on system or dataset. So, as of now, we need to use a metadata extractor adapter to make a common representation. The lack of open datasets for game summarization with multiple modalities of input is also an existing challenge. To be able to extract the information spoken by the commentator, we need a perfect speech-to-text system that works with noises, or we need a robust noise removal module to filter unnecessary noise in the game for better speech-to-text. We found this to be a challenge as well. We are excited by the initial results and want to improve the pipeline. The first thing, as per our interest, is to control the length of output of the summary from the long former. Currently, the length cannot be controlled and there is a huge variation in the length in the output. Likewise, the effectiveness of the priority filter module is not yet evaluated. We would like to see how summaries can be affected with different modalities of configurations of the filter module. This work lacked subjective human evaluation of the output. We would like to evaluate how the summaries output sounds to the real audiences. To address the challenges due to lack of multimodal data or datasets for game summarization, we are continually looking at opportunities for dataset curation and extending existing datasets from a summarization perspective. With this work, we contributed to the curation and extension of variety of soccer datasets that can be useful for soccer game summarization. We hope that this can help to bridge the gap due to the lack of multimodal dataset in English. We also created an open source and audio intensity dashboard to visualize the relationship between events and audio intensity levels. You can visit the repository on GitHub through the QR code shown on the screen to access the extended datasets and audio intensity dashboard. The key contribution of this research is a pipeline that can generate soccer game summaries from multiple input modalities. We also reported the preliminary finding on summarization using various input modalities and found that long text transformer model like long former has potential of being used for soccer game summarization. In addition, we identified multiple open challenges in the game summarization domain and the future steps that can be explored. These are some key references that has been inspirations for our work and used in the paper. Some more of them. this, we are at the end of the presentation. Thank you for your attention.